All right, hi, thank you for having me. It's great to be back at Practical Cartography Day for a second year. Today I'm going to be talking about GL mapping tips and tricks and how to use the latest features in Mapbox GL. My name is Molly. I work on the Mapbox GL team out of San Francisco. So what have we been working on this year? Last year I was here talking about data-driven styling, and we have a lot of new stuff that we hope you will be excited to use this coming year. So we have some new features that have just launched, heat maps, client-side hill shading with raster digital elevation model tiles, something we're calling expressions, which I'll get into more later, and a bonus, which is not a built-in Mapbox GL feature, but I thought this crowd would enjoy some projection hacking using Mapbox GL. So heat maps. Error. Well, so this just merged into master on GitHub last week. It's a new layer type that's in core Mapbox GL.js, and there's an open pull request to add it into native. And it uses, fast GPU calculations to produce this heat map. If anyone can guess what this data set is, let me know, but not quite. Heat maps are perfect for large point data sets when you want to show density. I won't get into the mathematical definition of what bivariate kernel density estimation is, but basically it just it calculates the density of points in a certain area and additively and uses that additively on the color ramp to determine the color of the pixel on the screen. It's super fast, as you could just see. This layer type was developed by Vlad, who is on our team, and he is the original author of Leaflet as well. He's really into performance, so you can always expect when he puts out a new feature, it's going to be super fast and performant. I don't know why this is formatted weird, but you can use data-driven styling in this to add variable heat map weight to your features. So for example, if you were going to make an earthquake map, you could weight the heat map points by the magnitude of that earthquake. And this is kind of small, but this is the code that you would need to add that heat map to your map. It should look familiar if you're used to using Mapbox GL. The properties that we're adding are heat map color, so the color ramp that you want your heat map gradient to be, the radius, so basically the radius of the kernel, which is what the area that is used to add up the points that are in that area. And so here I have it, the area of the kernel increasing from 5 pixels at zoom 0 to 20 pixels at zoom 10, and then the intensity, which is the sort of overall opacity of the heat map by zoom level as well. The next feature is something that I worked on for the past couple of months, so I'm really excited to share with you. This is raster DEM hillshade layer type. So Mapbox started offering this terrain RGB tile set, which is a digital elevation model, last year, and it's been used so far primarily in our Unity SDK for making augmented reality games, but we're adding support for client-side hill shading in Mapbox GL.js and eventually Mapbox GL native as well, using those tile sets. And I will just show what this looks like compared to the current Mapbox Outdoors. Hopefully you can see this, but this is the Yosemite Valley in Mapbox Outdoors, which is our current style for hiking maps or any kind of outdoor use case that we offer on Mapbox Studio. And the way the hill shading is done here, it uses pre-generated vectorized polygons from a raster DAM, but the vector tiles just have those pre-generated polygons to generate the areas that are shaded on the map. And the difference here is that in the client-side hill shade version, it's calculated on the fly using the raster DEM, and we're calculating the slope and the aspect, which is like the relationship to the light source on every frame of the terrain that's being displayed. And the neat thing is you can change the color of the light, the color that you want the shadow to be, and also you'll see you can rotate the map and the light source stays fixed. So, you get kind of a more realistic effect. And as you can see, it's like, fake 3D, but it looks much more realistic than the vectorized polygons, and that's because we're kind of constrained by the size of the data when we vectorize those hillshade polygons for the current Mapbox Outdoors. So we're really excited for our outdoor use case users to try this out, and hopefully their users will like it a lot too. The next thing I'm going to talk about is expressions. So what are expressions? So expressions are what we're calling this new capability in styling Mapbox GL maps that allow users to access multiple feature properties, do arithmetic on those properties, string manipulation, so you can concatenate, you can transform to upper and lowercase. You can use conditional logic for your style rules to, if whatever property exists, style it this way. If not, style it this way, that kind of thing. And in Mapbox GL.js, this will be backwards compatible, so don't worry if you've spent some time getting used to data-driven styling and creating map styles with data-driven styling. Those will still work. This is just an added functionality that we're introducing. So why? This is sort of the next frontier after data-driven styling. Data-driven styling was awesome, but it didn't allow users the full data access and control that they wanted in making a map. Simple things like converting from metric to imperial units, or doing simple mathematics or concatenating strings were out of the question using data-driven styling because that only gave you access to one style property. So with expressions, we're letting users really dig into their data. You don't have to do as much pre-processing because you can do it on the fly in your style sheets. And it works really well for styling that you would think of like just changing colors or line widths or things like that, and for creating dynamic labeling. So how do you use them? So here's an example of an expression that uses conditional logic and multiple properties. And this is a real example from the work that our cartography team is doing to convert our core styles to use expressions. So basically the first argument in an expression is the expression type, and in this case, it's case, which is our conditional expression type. So if that's followed by the if statement of the conditional, which is if the feature has the property name _ZH, which is like Chinese name, then you do the next argument, which is a nested expression. So these expressions are going to be very flexible because you can nest them as you wish. You can create, unlimited nested expressions if that's what you need. So in this case, if that property exists, we're combining the Chinese name and the default name property and displaying both. And if not, we're just displaying the default name. So that's something that you couldn't do with the old data-driven styling. Here's another example of arithmetic. Again, the first argument is that expression type, which is this exponent, and then we're getting the population. This is another nested expression, and then we're basically raising the population divided by 10,000 to the 0.5 power, which is the same as taking the square root. So there's a lot you can do. Obviously, expressions can get much more complicated than this, but I just wanted to give a brief introduction to what those might be useful for. So when would you be able to use these? In JavaScript, they're already merged into master, and they'll be released later this month, so you can test them out there. iOS and Android will be mid-December-ish, and then Mapbox Studio should be shortly following the mobile SDK releases. Our studio team is working on completely redesigning the UI to allow people to edit expressions in an intuitive way. So the last one is a bonus trick that I thought you'd be interested in. It's on hacking vector data projections. So this is from our friends at Development Seed, a colleague of mine who worked at Development Seed and now works at Mapbox, and some of his coworkers wrote this NPM module called Dirty Reprojectors, which is a way of hacking vector data to display it in a Mapbox GL map or any other map that supports Mapbox GL vector tile spec, but displaying a different projection. So there's an app that they have online called at devseed.com/dirty reprojectors app, and you can play around here. But as you can see, this is the world projected in a bond projection, but you can change it, for instance, to Albers, and it's a full Slippy map, and this is rendered with Mapbox GL. And the reason they did this was because they were working with the Washington Post on their projection maps, and the Washington Post was very stubborn about wanting to use an equal area projection for those choropleth maps, which I'm sure a lot of people here will appreciate. And so this is what came out of that. So if you've ever found yourself wanting to use a Slippy map but not Web Mercator, I definitely suggest you check out Dirty Reprojectors. Mapbox GL, both JS and native, are open source, so please hit us up on GitHub if there's features that we're missing that you want to request, and you can search around in there and see what we're working on. Everything is public and visible. And if you have any questions about using Mapbox GL, I would be happy to answer them here at the conference if you come find me, or you can hit me up on Twitter, and I'll try and get back to you as soon as I can. Or you can ask me right now, because I'm done.